In this video, we're going to look at an example similar to homework 9.4. We want to find the probability of some region. So for example, if we know t is less than negative 1.061 and we want to find out and the degree of freedom is 22, we want to find out the probability of this region. And we know in the middle value corresponds to t equal to 0. And if t is negative 1.061, it's somewhere here. So this value is negative 1.061. So this question is different from the homework problems from 9.2 and 9.3. In 9.2 and 9.3, the area is given, which means the probability is given. And we're looking for a t-value. But this one, it's given a t-value, and we're looking for the probability. And so let's see, if I draw a line here and we want to find out t less than, it means it's the left side of this value. So that's the left side of this region, negative 1.061. And we want to find out the area, or you can say the probability, because the probability equals the area under the curve. So if we go into the table, we find the negative 2 degree of freedom 2 right here, this row, and then we found out the value that is negative 1.061. Actually, we don't have negative here, we only have positive 1.061, and you will go up to see this corresponding alpha value, which is 0.15. So that means this area under the curve is 0.15. Okay, in fact, that is because in the table the value is positive 1. It's the opposite of negative. It's the positive 1.061 from the table. And if we draw the line, and the area to the right side, again, it's different from the standard deviation. For t-distribution, you will find the area to the right side, and this from the table it tells you it's 0.15. 0.15. But by the symmetry, if this area is 0.15, that means the left side area is also 0.15. So that's how we, for the negative area. So that means the probability for this region, if t is less than negative 1.061, the probability equals 0.15. Okay, the one thing we do need to notice here is that for standard normal distribution table, the value in the table means probability, and the row and the column, that's the z value. But for t-distribution, the probability or the area under the curve is this row, this row numbers, and all the values here, that means the t-value. So it's opposite of the table we used before. And we can look at another one example. What if we found out we want to find the area between these two values? So if I draw another picture right here quickly, so in the middle, that's 0, and we have negative, for t-value, the horizontal line, negative 1.061, and the positive 2.074. So t is between these two values. And so if we draw a line, the area, we want to find out the area between these two. Okay, so what we do is we're going to use the table to find out the area of this region right here. Mark it, use white red color, because the table only tells us the right side area. So let's find out what this is, and we can also find out what this area is. If I use blue color, and we find out this area is, and then we take both the red area and the blue area from 1, and then we get the green area. So that's between these two values. So let's use the table. Degree of freedom is still 22. So going to the table, degree of freedom is 22, and the value is negative. If it's negative 1.061, we only have positive. Notice we just need to put negative, the area is the same as positive, so 0.14. The area under the curve is 0.14 as before. Okay, because if this side, again, if this side is 0.14, and that makes this side 0.14. And 2.074, so let's find 2.074. It's right here, and if we look at up, we find out that the area is 0.025. So 0.025, and we want the green area. The green area, we would do 1 minus 0.025, that's the red area, and minus the blue area, 0.15, and this will be the area of the green area. Okay, so we will get 0.975 minus 0.15, that equals 0.825. So the probability for the green region, or you can say the area under the curve of this green area, is 0.825.